We're looking at histograms today. A histogram is pretty much, guys, a very fancy name for bar graphs. Okay? It's bar graphs. So, one of the main things that they test you on with histograms has to do with the shape of your histogram. Okay? I want us to actually start with this one, symmetric. You know the word symmetrical basically means it's a mirror. They're matching on one side and the other. So if we were to split this down the middle, it would be basically identical to the other side. Okay? That's what makes it symmetric. Now, up on these two, I want you to put a star in your blank space. Where the star is the direction that it is skewed. So this one right here, this bar graph, you notice all the blank space is on the left. So we call that skewed left. And if you can't remember the word skewed, then just remember the word starred left. And if you see it on a test, you'll probably remember, starred and skewed are the same thing in this case. Over here, when you have all the blank space on the right, we call it skewed right. Okay? It's basically where the tail is. We kind of think of it like a tail. That's the direction. Okay? I like to draw the star because, to me, I would look at this one and think of it as right because all the data is on the right. But with the shapes with this, it's not that way. It's the opposite. So the star's over here, the star's over here. So this is skewed left, skewed right, wherever the space is. And then on the symmetric one, there's two stars because they're even. It's symmetrical. So if we look at this first question, it says, the distance in miles that some students live from school to school is shown in the histogram. Which statement about the data in the histogram is true? What do you notice about this one? It's symmetrical. So looking at my answer choices, just by glancing at the beginning of all of them, I can narrow out two of them. If this is symmetrical, then it's definitely not asymmetrical, which would be the opposite, not symmetric. So I can cross out A, I can cross out B, and I'm left with C, and I'm left with D. Now, when you look at a symmetrical graph, this is only true of a symmetrical, your median is going to fall within your largest or your center point of data, or the peak, which we've called it in the past. Because if you were to start counting from left to right, you're going to count off 2 times here, 2 times, and you're going to just keep going, and eventually you would get to the middle. Okay, so your median, the middle number, is going to fall here. Also, your mean is going to fall there. When they find the average of something, the average falls within that highest peak of the graph. So if you look at your answer choices, it says the distribution of the data is symmetrical. So the mean and the median are likely outside of the 2.1 to 3 mile category, which is this one. Are they going to be outside of it over here or over here? No. Or are they going to fall within that category? Within. Okay. Now, look at your next graph. Can we call this symmetrical? No. No, it's not a mirror. I would probably call this skewed to the right because that's where I see the most open space. This is really not. Okay? So, looking at your data, A says more than half of the people are in the 65 to 80 age range. If we come over here, and you count, you have to go across and count how many people. So here's what I recommend you do, guys. When you get a histogram, write the number of people above each line before you start looking at questions. So this one's 4. This one's 2. This one's 8. 3. 1. We're looking at the 65 to 80 age range. There are 8 people in that age range. We're going to make this a bracket. fraction to see if it equals 1/2, if it can be reduced to 1/2, okay? A fraction is part over what? Whole. So we have to see how many are in the whole. So if we have 4 plus 2, we get 6. Plus 8, we get 14. Plus 3 is 17. Plus 1 is 18. So now, if we reduce this, divide them both by 2, because they both are even, we would get 4 over 9. Is that 1/2? Is 4 over 9 half?
No.
Is it more than half?
No.
It's less than half, right? 4 over 8 would be half.
Oh.
4 over 9 is not, so we're going to say no, it's false. Let's look at B. The number of people that are in the 95 to 100-year-old range, which is how many? 1, is twice, meaning 2 times the number of people in the 50 to 65, which is 2. Is 1 2 times a 2?
No.
No, that's opposite. This age range would be twice of this one. So that's also false. And then the last one, C, the number of people that are 35 to 65, they're combining categories. This one to this one, how many people would that be? 6. Is less than the number of people that are in 65 to 80. How many are in that category? 65 to 80. 8. Is 6 less than 8?
Yes.
Yes, so that one would be true. Okay, flip it on the back. First thing I want you to do is write your totals for your histogram. So this is 45. This is 15. This is 30. This is 10. Okay. It says, which statement about the employees is supported by the data in the bar graph? I want you to try this one on your own, and then we're going to go over it.